Alright, this is our video on the characteristics of the groups of the periodic table. Remember, groups are those vertical columns, so we'll be talking about each of those vertical columns, the groups, and their characteristics. Our objectives for today: I can use the periodic table to identify characteristics of elements. I can use the periodic table to determine valence electrons, and we're going to talk about what valence electrons are. Okay, quick review. We know metals are on the left side of the table. Remember, we have our little stair step here. Metals are to the left of that. Metalloids are going to be on the stair step, and then nonmetals are to the right. Okay, remember our vertical columns or groups are called families. Families and groups are kind of interchangeable. We can use either word. Elements for the periodic table, they're grouped in families based on their chemical properties. So every family, every group of elements in a vertical column have similar chemical properties. And we give each of those groups a name so we can talk about the whole group and identify it. Each family has a set of chemical properties, and those properties are different from the other families. They react differently with other elements. Chemical properties, or how they react, are determined by the number of valence electrons. There's that word again, valence electrons, and we're going to find out what that means. So we have talked about how protons and neutrons are in the center nucleus, and that electrons move in a cloud around the nucleus. Well, they are a little bit more organized than that. Electrons are around the nucleus in layers that are called shells that are kind of pulled towards the nucleus, kind of like gravity on Earth. Things that are on Earth are pulled towards the center. So all those electrons in those shells are kept in these kind of layers by the pull from the nucleus. The electrons that are in the shells farthest away, so we put a few electrons in the first shell, then we go out to the next layer, and the next layer, and the next layer. Those electrons that are in the shell farthest away, they're really hard to hold on to. It's almost like if, when you're on the moon, you're far away from Earth, so the gravity isn't as strong. So when you're the electrons that are farther away, they're harder to hold on to, so they can be lost easily in reacting with other elements. These electrons that are in the outermost shells, the ones farthest away, are called valence electrons. So anything in the outermost shell, the electrons in the shell farthest away from the nucleus, are called valence electrons. Remember, when an atom loses an electron, it becomes positively charged. The chemical properties of an element, which chemical properties are how it reacts with other substances, that's determined by how many valence electrons. The elements that are in the same family have the same number of valence electrons, which is why they have similar chemical properties. That's why they react in the same way with other elements, because they all have that same number of outermost layer electrons. So let's talk about the first group or family. These are called the alkali metals. Their members are lithium, sodium, potassium, rubidium, cesium, and francium. They all have one valence electron. There's only one electron in that outermost shell. Of course, they have more electrons than that, but the other electrons are in shells closer to the nucleus. Hydrogen is not a member of this group, but it is put at the top of the group because it also has one valence electron. So it's not an alkali metal, but it still goes in group 1. It doesn't, it's a nonmetal itself. Alkali metals are very reactive because of that one valence electron. They are so reactive you don't find them alone in nature. They'll react with anything they can find. These metals tend to be solid at room temperature. They are soft, relatively speaking, not like, fuzzy kitty soft, but soft for a metal. Silvery, shiny, and then they conduct electricity. Next group is the alkaline earth metals. These members are beryllium, magnesium, calcium, strontium, barium, and radium. These have 2 valence electrons. Alkaline earth metals are also reactive, but not as much as the alkali metals. So they also are not found alone in nature, but they're just not quite as reactive. They also are solid at room temperature, white, silvery, malleable, which means they can kind of be manipulated and used. We'll talk more about that when we talk about physical characteristics in another video. And then they also conduct electricity. The next rather large section are called the transition metals, and we kind of group them all together in families 3 through 12, or groups 3 through 12. Some common ones you've probably heard of: copper, tin, zinc, iron, nickel, cobalt, gold, mercury, and silver. These are all also solids at room temperature. Mercury is an exception. It is a liquid at room temperature. They are good conductors of heat and electricity, like all the metals. They tend to have bright colors, and they will either have 1 or 2 valence electrons. They are less reactive, but they can bond with many elements. After this, in the next video tomorrow, we are going to talk about the last few groups, which are the metalloids and nonmetals. And we're going to talk about those properties and the trends that we see as we're moving from left to right in the periodic table.